That's weird. Okay, so a sphere with a mass of 8 kilograms is moving at 1 meter to the right until it smacks a secondary sphere with a mass of 5 kilograms. After the collisions, both spheres travel to the right. The first sphere at 0.231 meters per second, and the second sphere at 1.2. What kind of collision took place? So this one, there's a lot of math on this, right? So there's two things we need to determine. If the kinetic energy was conserved, and then obviously the momentum was conserved. And so let's start with the momentum, right? So I like to draw the picture. So I have sphere 1, perfectly drawn sphere, 8 kilograms. And that's moving at 1 meter per second, 1 meter per second to the right. And we should probably identify that going to the left is negative and going to the right is positive. Then it hits a secondary sphere, which is stationary, which is 5 kilograms. And this is going 0 meters per second. And then there's a collision, right? Boom. And then after the collision, my 8 kilogram, I don't know why, I'm running out of room here is the problem. My 8 kilogram one is traveling at 0.231 meters per second. And it sends this second one flying. So this is 5 kilograms still. And that has a velocity now of 1.23 meters per second. All right, so conservation of momentum is just, we're going to have m1 times v1. Remember that momentum is m times v. So we have m1 v1 plus m1 v1, or v2, I'm sorry. And so this is the initial momentum. This is the beginning before the collision. Then we have the collision. We'll call that boom. And then the final momentums. So we have m1 v1 plus m2 v2. All right. All right, so I'm just going to plug and chug. This one's going to be 8 times 1 plus 5 times 0. And that should equal, over here on this side, 8 times 0.231 plus 5 times 1.23. Okay, so then this just ends up equaling 8 kilogram meters per second. And then over here, if you do the math on this, this also equals 8 kilogram meters per second. I mean, they did some rounding, but thank you. So congratulations, momentum was conserved. That's the first part. Now, technically, because they're not doing the same velocity, we know they didn't stick together. And if they didn't stick together, it wasn't inelastic, right? So we already kind of have our answer because based on the information they've given us. But we should double check the kinetic energy to make sure it's conserved, because sometimes they won't give us all this information. So next we got to check the kinetic energy. So remember that kinetic energy is equal to 1/2 times the mass of the object times the velocity. So again, we're going to check the initial kinetic energy. And then there's the collision, boom. And then we're going to check the final kinetic energy. So now, because my velocity is 0 on that second item, I really only need to do 1/2 times the mass times the velocity squared. Well, let me just write it out. Plus 1/2 times, so this is m2 v2 squared, and then this is m1 v1 squared, the initial. Then we have our collision, and then we're going to check the final kinetic energy, 1/2 times the mass of the first object times the velocity of that object squared, plus 1/2 times m2 v2 squared. Okay. All right, so we just got to plug and chug this thing. So because v equals 0, that whole thing goes away. So on this side, I just need 1/2 times the mass, which is 8, times the velocity, which was 1, squared. 1 squared is 1, times 8 divided by 2. This whole thing is just equal to 4. So far, so good. Over here, I have 1/2 times the mass times the velocity, which was 0.231 squared, plus 1/2 times 5 times 1.23 squared. And so that is also equal to 4 joules. Okay, so we see that the kinetic energy is conserved. So that makes this, I think I may have misspoke earlier. It's an elastic collision. Did I say it wasn't an elastic? I can't remember what I said. It's hard to write this stuff down. But anyways, this is elastic, right? So somewhere in your notes, remember for elastic, kinetic energy and momentum are conserved. Sometimes I watch these videos back after I do it, and I realize I misspoke because I was thinking. And then I go, ugh. But I think I said it right. We know that it's not inelastic because they didn't stick together. Does that make sense?